Hello, greetings everyone. Today we are going to look at a solution for minimum and or it's a problem from codechef starters. This problem states that chef has been recently introduced to a bitwise operators, and chefina defines the function, which is this, and we have given three non-negative integers a, b, and c. Chef has to count the number of integer x such that uh, the x is less than or equal to 2 raised to power c, and we have to find the maximum possible value among all the values of x. Okay. Uh, okay. So all the possible values which are the maximum values of x. So this problem can be stated like this. So we have given three integers like x we have to find, okay, and we have given a, b, and c. Okay. C is nothing but c is the maximum bit we can choose as an active or not active, because this x goes to 2 less than or equal to 2 raised to power c. So we have this limitations. Okay. Okay. So according to the problem, the function which they have defined is function is like r or p. Okay, I'm sorry for the r, and minus q and p, minus q and p. So this is for this function is for pqr. Okay, this function is for pqr, and if I replace this function for x ab, so the function will be like b or x minus a and p. Okay, so we have given these two numbers. Okay, and for the maximum value, let us suppose that the maximum value is m dash, and this m dash value should be given by all the possible x, x1, x2, x3, so that, and we have to count all those possible x's for which the m dash is the maximum value of this function. So this is the question. So I've done this question by forming an logic array, or you can do it like this. I've implemented all the possibilities like 1 1 1 1 0 0 0 and 0. These are 4 zeros and 4 ones. And for b, this is for a. Okay, the possible bits that we can get as an input, this is an a and this is an b. So b can be like 1 1 0 0, again 1 1, and then again 0 0. Now for x, okay, now what can x be? X can be either 1 0 1 0. So this type, in this way we have covered all the possible permutations of one a, b, and x, what their bits can be. So according to this, we'll have to choose the maximum value accordingly. Okay, like, so let's take m as a maximum value. So for a equal to 1 and b equal to 1 and x equal to 1, so if we put a equal to 1, b equal to 1, and x equal to 1 in this equation, okay, what we have formed, so we will get this as 0. Okay, maximum value is 0. Why? So let us try to put b is 1, x is 1, 1 or 1 is 1, minus 1 and 1 is 1, so this is 0. And for 1 1 0, it will be 1. Okay, so it is 1. So in the case of 1 1, I think I don't have to put the values in this equation to provide, but to prove it. So for this it is 1. So it can be seen evident that if there is 1 and 1 as a both bit, so the only possible value that I can choose is 0, because in this our bit has the maximum value 1. Okay, because for only 0 this is 1, and but for 1 this is 0, so we cannot choose this. So here is our restriction, that for 1 1 we can only choose 0. Okay, now we come to this part. So for 1 0 and x 1, we can get 1 as an output, and for this also we can get 1 as an output. So when we have a and b 1 0 and 1 0, we have choice. We have two choices in the x, like x can be 1 and x can be 0 also. Okay, x can be 1 and x can be 0 also. So we continue. Okay, let's form this array first, and then I'll talk about the logic of the question, code part or the implementation part or the algorithm part. So this is a basic intuition in which we are constructing the logic. In further time I would tell you the logic. And for this part, both these answers and both these values gives 0 and 0, and for this both the values gives 1 and 0. Okay, so it is understood that when our a is 1 and b is 1, we will have to only choose x as 0, and if I have a as 1 and b as 0, I can choose either of them, I will get the maximum value. Okay, and if our a is 0 and b is 1, I can choose either of one, I will get 0 only. Okay, I know it's not the maximum, but 0 itself is the maximum in this comparison, because we're comparing it with these two only. Okay, and if I have 0 0, I can only choose x as 1, because only this case I'm getting the maximum value. Okay, so this is our basic architecture, or you can say intuition for the logic. Now let us take an input, like c, we would take c equal to 4. Okay, and we'll choose a number, like we can discuss an example test case, not a problem. 1 2 3. Okay, so they've given c as 3 and a as 1. Okay, and b as 2. So 1 0, 2 is represented as 1 0. So I can choose the value of x up till 3 bits. Okay, so we will try to choose the first bit. Okay, we will try to choose the first bit. Okay, so let me put the leading zeros. Okay, so for 1 0, I have discussed that 1 0 I can pick these two values. Okay, so I can pick two values here. Okay, and for this 0 1, for this 0 1, still I can pick two values. 0 1, I can pick two values. Okay, so second bit also the two values can be chosen, but for the third bit, in the third bit both the values are 0 and 0, so only one bit can be chosen. Okay, so according to the permutation combination, so there are two ways of choosing this bit, and there are two ways of choosing this bit, and there's only one way of choosing this bit. So we will what we'll do, we will multiply them. Okay, so if we multiply them, we'll get 2 into 2 into 2 as 4. Okay, so this is the basic and simple solution. What we can do is I can show you the code part. So this is the code for the problem. What I have done is I have taken input a, b, and c. Okay, and answers as 1. So they can only be c bits. So I've done this loop runs c times. Okay, and in each time I'm choosing bit of a and bit of b by doing a and 1 and b and 1, and then I'm doing, if b a equal to 1, then answer should be multiplied by 2 and b equal to 0 only, and if b a equal to 0 and b equal to 1, then answer should be multiplied by 2, and then what I'm doing, I'm right shifting both these numbers so that I could get the last bit of the problem. So this is the problem solution. I hope you like it. Please like and subscribe.